Our focus last week was finding the LCD. First we added and subtracted with like denominators, and then Friday we went around how do you find the least common denominator, because that's what you're going to need. You can get away with not doing that in algebra and just multiplying the denominator and arithmetic by just multiplying the denominators together. Life is easy because then you can reduce out the numerical fraction. But in algebra, it can be just an absolute nightmare. So here we go. It says, first of all, you're going to find the LCD of the denominators of the fractions. Write each fraction as an equivalent fraction whose denominator is the LCD. Add or subtract like fractions. Write the sum and difference in simplest form. And essentially what they're saying is this. I've got two things that I want to count, and the denominators, they're not the same size. If I want to know how many of these things I have, they have to have the same denominator. That means they have to be the same size fraction. So I first want to find what's the LCD. In this case, 3 and 11 have nothing in common, so it is 33. I am going to take 2/3 and write it with a denominator of 33. I'm going to multiply by 1, but a 1 that maintains the value of the fraction. If I were reducing 22, and it turns out to be 22 over 33, if I wanted to reduce 22 over 33 down, I take 22 is 2 times 11, 33 is 3 times 11, the 11s reduce out, it becomes 2/3. So that says I'm taking something and I'm multiplying it by 1, it turns into an equivalent fraction. Same value, just looks a little different. The same thing's going to happen with 10 over 11. In this instance, I'm going to multiply by 3 over 3. 3 over 3 is 1. 3 in the numerator gives me 30. 3 times the denominator gives me 33. Now 10 over 11 is 30 over 33. So in their equivalent fractional form, 2/3 minus 10 over 11 is 22 over 33 minus 30 over 33. Now I'm counting how many 33rds I have. The denominators are the same. I just subtract the numerators. So this is going to come out to be a negative 8 over 33. That's how it works with arithmetic. So dealing with arithmetic again, to make the problem a little bit harder, it says I want to add 2 over 15 plus 5 over 36. Well, 15 times 36 is a very large number. However, what is the LCD? Well, the first thing I do is I look at what are the factors of 15. That's the first denominator. That's dem 1. Well, it's just 3 times 5. What about the second denominator? The second denominator is 36. And 36 is not so easy for me. This is 2 times 18, which is 2 times 2 times 9, because 18 is 2 times 9, which is 2 times 2 times 9 is 3 times 3. So 2 times 2 times 3 times 3. So what's the LCD? I take a look at building the LCD. And I'm just going to come over here and do this over here. What is it? Well, I first put in the first denominator, which is 3 times 5. Then it says, in order for 36 to divide it, it has to have 2 2s and 2 3s. Well, I need 2 2s. That gives me the 2 2s. And I need 2 3s. I have a 3 already. I need a second 3. So the LCD is 20 times 9. 5 times 4 is 20. 20 times 9 is what, 180? So that says I've got to turn these two denominators into 180. Now, how would I do that? Well, I take 2 over 15 added to 5 over 36. Thank you very much. And 15 has a 3 and a 5. That's this guy. What is he missing to get me to 280 or to 180? He needs a 4, a 2, and a 3. 4 times 3 is 12. Twelve over 12 is 1. So what am I doing? I'm changing not the value of the fraction, but his appearance. So that the denominator is going to turn into 180, the desired number, because 15 is 3 times 5, right? And to get me to 180, I need a 2, and a 3, which is 12. And so it's 24 over 180. Now, what about 36? How does 36 get to 180? Well, 36 is 2 2s and 2 3s. Well, 2 3s and 2 2s, what's missing? The 5. 5 over 5. So that says it's 25 over 180. Now I'm counting like things. I'm counting 180s. So that over 180, 24 plus 25 is 49. And then I say whoopee. Why do I say whoopee? 49 is 7 times 7, right? Is there a 7 in 180? No. That says I'm done. It's like, whoop, yep, I'm done. But that's exactly how you do it in algebra. Same way you would do it in arithmetic.